The unit circle, circular function. The unit circle is x squared plus y squared equals 1. So therefore, x equals cosine of s, y equals sine of s, and s is the arc of the length. So for any real number s represented by a direct arc on the circle, sine of s is equal to y. Cosecant of s is a reciprocal of that, so it's 1 over y, where y cannot equal 0. Cosine of s is equal to x. Therefore, secant of s is equal to 1 over x. Once again, it's the reciprocal. Tan of s is y over x, where x cannot equal 0. Therefore, cotangent of s is the reciprocal of tangent of s, which is x over y, and y cannot equal 0. So in the first example, I'm given a point, and I'm trying to find the values of the trig functions of t associated with the point p, 21 over 29, comma, negative 20 over 29, which is in quadrant 4. So sine of t is equal to whatever y is. So y is negative 20 over 29. Therefore, cosecant of t is the reciprocal of that, which is 29 over negative 20. Cosine of t is equal to the x coordinate, which is 21 over 29. Therefore, secant of t is equal to the reciprocal of that, which is 29 over 21. Tangent of t is equal to y, which is negative 20 over 29, divided by x, which is 21 over 29. We'll have that the 29s will cancel out, leaving me with that tan of t is equal to negative 20 over 21. Therefore, cotangent of t is equal to 21 over negative 20. Once again, it does not matter where the negative sign goes as long as it's one time in the problem. Example 2, we are given, once again, a point, which in this case is square root of 2 over 2, comma, square root of 2 over 2, and we're finding the trig function values associated with the angle t. So we have our point x, comma, y. So sine of t is equal to y, which is square root of 2 over 2. Cosecant of t is equal to 2 over square root of 2, the reciprocal. If I multiply by square root of 2 over square root of 2, that'll give me 2 square root of 2 over 2, which simplifies to just square root of 2. And then we have cosine of t is square root of 2 over 2. So secant of t is 2 over square root of 2. And if I multiply by square root of 2, we have 2 square root of 2 over 2, and the 2 cancels out, so it's just square root of 2. Tangent of t is equal to sine, which is square root of 2 over 2, over cosine, which is square root of 2 over 2. And that equals 1. And cotangent of t is the reciprocal of 1, which is just 1. So here I have the unit circle, and it is kind of basically using the triangles, the 30, 60, 90, and the 45, 45, 90 to create this unit circle. So if we label this angle 30 degrees, we know the length opposite to that is 1. If we label this 60 degrees, we know the length opposite to 60 is square root of 3, and my hypotenuse is 2. So when I do this 30 degrees, we have that cosine is the x value. So cosine is going to be adjacent, which is square root of 3 over 2. So that's why x is square root of 3 over 2. And sine of 30 will be opposite over hypotenuse. So notice the opposite of 30 degrees is 1 and the hypotenuse is 2. So therefore, sine of 30 degrees is 1/2. And that's how you would use this triangle to do everything with 30 and 60 and its reference angles. And for the 45, 45, 90 triangle, we know that the length across from the 45 degrees or opposite are 1s, and my hypotenuse is 2. And sine of 45 is opposite over hypotenuse, so it's 1 over square root of 2, and cosine of 45 is also 1 over square root of 2, and they just rationalize that to be square root of 2 over square root of 2. And so you're using those two triangles to kind of basically complete the whole unit circle in terms of reference. So the unit circle is symmetrical with respect to the x-axis, y-axis, and the origin. Thus, if a point AB lies on the unit circle, so does A negative B, negative A comma B, and negative A comma negative B. Even and odd trig functions. The cosine and secant functions are even. Therefore, if you look at cosine of negative t, that's going to equal cosine of t. And secant of negative t is equal to secant of t. The sine, cosecant, and cotangent are functions are odd. So sine of negative t is equal to negative sine of t. Tan of negative t is equal to negative tan of t. Cosecant of negative t is equal to negative cosecant of t. Cotangent of t is equal to negative cotangent of t. So I want to find the exact value of sine of 7 pi over 6. So remember, sine of pi over 6, if you know the unit circle, is going to be, we're using the y value, and it's going to be negative 1/2. Cosine of 5 pi over 3, well, that's the x value, so go to 5 pi over 3 on the unit circle, and the x value there is 1/2. Tan of 3 pi over 4, well, tan of 3 pi over 4, go to 3 pi over 4, and tangent is y over x. So that point is negative square root of 2, comma square root of 2, so y is square root of 2 over 2, divided by negative square root of 2 over 2, and that'll give me negative 1. Secant of 2 pi over 3 is going to be 1 over x, so go to 2 pi over 3, and the x value is negative 1/2, so it's going to be 1 over negative 1/2, or the reciprocal of negative 1/2 is just negative 2. Cosecant of negative 4 pi over 3, remember negative angles go clockwise, so go to negative 4 pi over 3. If you don't like negative angles, you can always add 2 pi, and you can get the positive coterminal. So cosecant of negative 4 pi over 3 is the same position or same coterminal as 2 pi over 3. So we have that this is going to be the same thing as cosecant of 2 pi over 3. And cosecant is 1 over y. So go to 2 pi over 3, and the y value there is square root of 3 over 2. So it's going to be 1 over square root of 3 over 2. And the reciprocal of square root of 3 over 2 is 2 over square root of 3. And if we rationalize that, that's 2 square root of 3 over 3. Cotangent of pi, well, we know we're at the point negative 1 comma 0. So cotangent is x over y. So cotangent would be x is negative 1, y is 0, which is undefined. The domain of a circular function. The domain of a circular functions are as follows. The sine and cosine function is negative infinity to infinity. Tangent of and secant functions are such that s does not equal 2n plus 1 times pi over 2, where n is any integer. And cotangent and cosecant function is s such that s cannot equal n times pi, where n is any integer. The definition of a periodic function. A function f is periodic if there exists a positive number p such that f of t plus p is equal to f of t. For all t in the domain of f, the smallest positive number p for which the periodic is called the period of the function. Periodic properties for sine and cosine functions. So sine of t plus 2 pi is equal to sine of t, and cosine of t plus 2 pi is equal to cosine of t. The sine and cosine functions are periodic functions and have a period of 2 pi, which means every 2 pi, all the points kind of repeat, or all the values repeat. The periodic properties of tangent and cotangent. Tangent of t plus pi is equal to tangent of t, and cotangent of t plus pi is equal to cotangent of p. The tangent and cotangent functions are periodic functions and have a period of pi, which means every pi they repeat. Repeating behaviors of sine, cosine, and tangent functions. For any integer n and a real number t, sine of t plus 2 pi n is equal to sine of t. Cosine of t plus 2 pi over n is equal to cosine of t, and tan of t plus pi over n is equal to tan of t. So find the exact value of cosine of 405. Well, what we're saying here is notice that to get cosine of 405, it was basically something plus 360. So I can just say 405 minus 360, which is cosine of 45, and we know cosine of 45, the x value on the unit circle is square root of 2 over 2. Sine of 7 pi over 3, we'll notice that that's also more than 2 pi, so we can say sine of 7 pi over 3 minus 2 pi is going to give us sine of pi over 3, and sine of pi over 3 is equal to square root of 3 over 2, use the y-coordinate. Now we're working kind of backwards, and we're looking for the angle between 0 and 2 pi that satisfies sine of theta equals 1/2. So go to the unit circle, look for the y-coordinate. So sine is positive, or y is positive in quadrant 1. So we have an answer in quadrant 1. So theta is in radians, it's pi over 6, or 30 degrees. And sine of theta is positive, or y is positive also in quadrant 2. So that would be at 5 pi over 6. Or as a degree, it would be 150 degrees. Example 10. We're finding the two values of s, exact values, such that theta is between 0 and 2 pi that satisfy secant of theta equals -2. Sometimes I don't like to think in terms of secant of theta, so I can rewrite this as cosine of theta, and the reciprocal of -2 is 1 over -2. So I'm looking for where cosine of theta basically equals 1 over -2. Cosine is correlated with the x-coordinate. X is negative in quadrant 2 and 3. So in quadrant 2, cosine of -1/2 is equal to 2 pi over 3. And cosine of theta is -1/2. Once again, we're looking at the unit circle on the x-coordinate, and it is equal to 4 pi over 3. We're looking for the angle this time. Example 11, tan of theta equals negative square root of 3. So you have to do a little work here. We're looking for basically the ratio. So in your mind, you'll have to do y over x, or you can write it on paper, where it equals negative square root of 3. So we know that tangent is negative in quadrant 2, because y is positive, x is negative, therefore that'll make it a negative value. And in quadrant 4, y is negative, x is positive, and that will make it negative in quadrant 4. So when we do y over x, and we use, let's say we use the 2 pi over 3. So I'm thinking the answer is 2 pi over 3. So I don't know yet. I'm going to verify that. So on 2 pi over 3, my coordinate is -1/2, comma, square root of 3 over 2. So we know y is square root of 3 over 2 over x is -1/2. And notice the 2's cancel out. That gives me negative square root of 3. So that is correct. 2 pi over 3 is one of my solutions. And my other solution is in quadrant 4, which is 5 pi over 3, and we're going to double check 5 pi over 3 as well. So for 5 pi over 3, x is 1/2, y is negative square root of 3 over 2. So when I do y over x, I get negative square root of 3 over 2 divided by 1/2. Notice the 2's cancel out, giving me negative square root of 3. So I know 5 pi over 3 is my other solution. Example 12, we have cotangent of theta equals 1, so the ratio of x over y has to equal 1. And that can only happen if x and y are both the same value. And that happens in quadrant 1 because cotangent is positive in quadrant 1 because x over y is positive over positive, which is positive, and in quadrant 3 because negative divided by negative is also positive. So where does the x value and the y value equal each other is that square root of 2 over 2 comma square root of 2 over 2, which is at 45 degrees or pi over 4, because we have square root of 2 over 2 over square root of 2 over 2, and that just gives me 1 is what I want. So we know pi over 4 is the solution. And the other solution is 5 pi over 4, because when I do negative square root of 2 over 2 divided by negative square root of 2 over 2, that also gives me positive 1.